is at rest, then there is an electric field associated with that. If it is moving in the uniform motion, then there is a magnetic field associated with that. So, for him it was a question that if a charged particle is moving, then there is a magnetic field associated with that. But if you are observing the same particle in a frame which is moving with the same velocity as that of the charged particle, in that frame the charge is at rest, so it has only electric field. So there seems to be a magnetic field in one frame and an electric field in another frame. If these two fields physically are different, how they can be physically one, because laws of physics should not change from one inertial frame to the other inertial frame. This was true also in Newtonian relativity. So, but here is a case where your electric field appears to be magnetic field in another frame. Magnetic field appears to be electric field in another frame. So, this seems to be the question that drove him to think and then develop special theory of relativity. Essentially, what turns out to be the case is that electric field and magnetic field turn out to be two different components of it. Electric field, classically, when we study Maxwell's equations, we call it as a vector field, and magnetic field is also a vector field. It turns out that there is a tensor field of which electric field is one component and magnetic field is another component. So electromagnetic field is a tensor. It's a tensor field of which electric field is one component and magnetic field is another component. So this is the resolution of the question which Einstein had after you develop special theory of relativity. So let us see how this is true. So we start with, so this is basically, we try to develop what is called covariant form of Maxwell's equations. Covariant form of Maxwell's equations, if we write, we will be able to develop a field tensor whose components will be electric and magnetic fields. So, we will write down the Maxwell's equations. Divergence of electric field is rho by epsilon naught. This is the Gauss law. And curl of magnetic field minus 1 over c squared into rho squared E by rho E by rho t is equal to mu naught into j. This is Maxwell corrected Ampere's law. And del dot B is equal to 0. And del cross E plus rho V by rho t is equal to 0 is the Faraday's law. I have written them in this form because these two equations are called inhomogeneous Maxwell's equations. Inhomogeneous because source terms are present. Source terms. What are the source terms? Charge density and current density are the source terms. These two are inhomogeneous equations. And the second two equations are homogeneous equations because right hand side there are no source terms. These are homogeneous equations. Now, in